Thank you. Well, hey, y'all. As you already know, I'm from the U.S. I'm from the South. I speak fluent redneck. So I hope it translates well. I am excited to be here. It's quite an opportunity, and I'm very, very grateful. Do you have things here like 12-step programs, like an AA and so forth? Well, I am in recovery for type coercion and automatic semicolon insertion, and my name is David Neal. This is a safe place. It's okay to admit, the things that we struggle with, and confidentiality is respected. By show of hands, how many would admit that you've been burned by JavaScript? Right. You know what I'm talking about. We're in good company here. Well, my first introduction to JavaScript was back in the days of around 1997. I was a Visual Basic developer at that time, making the transition to doing ASP, which we now affectionately refer to as classic ASP. And I started building web apps, and I kept hearing about this thing called DHTML. Dynamic HTML. That sounded like something I wanted. I wanted to be able to make my web pages more dynamic. And then things started to really get serious. In 2000, I was hired to build an interactive web app for a commercial software company, and I needed to support both IE and Netscape, which, if you remember those days, IE was everything was a challenge in those early days of the internet. And I spent a lot of time at this website called Dynamic Drive, trying to understand the JavaScript that they had on this website, and then being really frustrated. I'd copy JavaScript that was running fine on their website, put it on mine, and it didn't work at all. And there was no things like Firebug or Chrome DevTools or anything to try to help you to figure out what was going wrong. And JavaScript, doesn't give you the best error messages. So I learned JavaScript the hard way, and I wasn't too happy about it, at least not at that time. As you probably know, anything goes, and it often does. With JavaScript being a dynamic language, it has some amazing capabilities and features, but it also creates a lot of weird behavior, and those quirks and those weirdness continue to exist even to this day, and that those unexpected behaviors can baffle even the most seasoned JavaScript developer. Let's take a look at some of those examples of quirky behavior. As you probably know, nan in JavaScript is not a number, and which, not to be confused with null or undefined. Those are totally separate things. But let's say, given this expression, or this statement, if the variable f, which of course it's f, is nan, then everything is nan. And anytime there's any part of an operation that is nan, it all evaluates the nan, which is sometimes very difficult to find. There's no clue as to where this happens. And so JavaScript has a type of type system, right? And we can, so how do we figure out what nan is? Well, is nan greater than or equal to 0? No. Is it less than or equal to 0? No. But what is the type of nan? It's a number. Fantastic. Thanks a lot, JavaScript. In math, we have something called commutative properties. We know the statement is always true, that A plus B plus C is going to look like, it's going to always equal that. But in JavaScript, when we evaluate a statement like this, we don't know. Because there's certain conditions where it may be true and certain conditions where it may not be true. For example, if we say 0.1 plus 0.2, is that equal to 0.3? No. That's obvious, right? It's predictable. But what is 0.1 plus 0.2? It's this. Well, okay, so this is not just a JavaScript problem. This is a problem with any dynamic language, and apparently floating point math on computers is hard. We haven't figured that out yet. But here's an interesting thing. If we round this number, we get what we expect. We get 0. But if we take this same number, and all we're doing is changing the 2 to a 3 on the very end, now we get 1. This is incredible. I want to know what poor soul found this bug. How in the world do you discover one is 0 and that one's, yeah. Let's talk about arrays and sorting those arrays. So when we sort an array, we get what we expect. That's always helpful. And then when we say we want to map, and we map an array of a bunch of 10s, we get exactly what we expect. Some of these, bear explanation, but I'll let you look it up for yourself. That one still baffles me. And then we got, our lovely duck type system that allows us to do all kinds of, weird things. And, we've got some types in JavaScript that make a whole lot of sense. We've got true is Boolean, strings, numbers, objects. And then we start looking at arrays. Well, it's not an array. Null, no, it's still an object too. So it's really helpful to, be able to use the type system that's in. Yeah, good luck. Let's talk about null. If we use null, passing that into a number, we get 0. Cool. Is null equal to 0? No. Is null greater than 0? No. That kind of makes sense, But is it greater than or equal to 0? Yes. Fantastic. And then there's this concept of falsy, truthy kind of things. That false is false, but also anytime we evaluate nulls, that's also false. Undefined is evaluated as false. Empty strings are false. 0 is false. Nan's false. All kinds of conditions that give us the wrong, expectation of what we're trying to evaluate. What about regular expressions? I had a problem. I solved it with regular expressions. Now I have NaN problems. But regular expressions are kind of like that programming challenges, like challenge accepted. I've solved a lot of problems with regular expressions. I just can't figure them out when I go back, 6 months later to figure out what went wrong. But let's take an example of we're looking for a string. We're defining what to be a string. We're looking for the letter A. And if we test JavaScript, then we get true, exactly what we expect. And then we test what are you doing, we get false. Now this has to do with the regular expression that we've defined actually maintains state. And so after we test it the first time, it automatically advances the index. So it wants to look for the letter A after the position of 1, and it doesn't find 1 in the second string. that's really helpful. So there's syntax quirks as well. So given this function, what should troll return? It should return undefined because we've got automatic semicolon insertion going on here. So the curly brace actually has to be in the right spot for this to work, because JavaScript is very helpful in thinking, oh, well, you've got a return statement there, and we'll just go ahead and throw in a semicolon for you. Yeah. So let's talk about arrays. Arrays are, in JavaScript, just like everything else in JavaScript, are dynamic. You can start stuffing things into an array any way you like. So we can say arrays index 1, 3, 10. What is array.length now? 3. You would think, but no. It's 11. Well, let's do some other fun stuff. We can say index -1. We can say array.s equals 5. We can do whatever we want. It's a dynamic language. So now what's array.length? It's 11. Why? Why is JavaScript so, how did this happen? JavaScript, arguably the most important, popular, ubiquitous, universal language that's been created in computer science. If it's so important, why is it so terrible? And the birth of JavaScript is that classic example of how many things get created in the software world. And it's funny, but it's the kind of funny that makes you want to cry. This is Mark Andreessen. He was one of the University of Illinois kids at the NCSA Mosaic, and he left there and moved to Silicon Valley to help start this company you may have heard of called Netscape. In February of '95, after making a metric buttload of money, which is a unit of measurement, they hire this guy, Brandon Ike. He was hired to create a scripting language for Netscape. And the original plan was for him to implement Scheme, which is a dialect of Lisp, in the browser. In May of '95, Andreessen calls in Brendan. This is my, interpretation of the history that I've read. He calls him into his office and says, "Brindle Pants, we need a demo of that scripting language like yesterday." "It's Brendan, sir, and yes, this scheme in Netscape is going to be fantastic." Right, scheme in the browser. That's hilarious. No, seriously though, it's got to look like Java, and let's call it Mocha. Mocha, Java, get it? Well, we need a demo by the end of the week, and need you to come in on Saturday and Sunday too. So what does Brendan do? He does what any of us would do in his situation, and any of us have done in a similar situation. He frickin' gets the job done. And 10 days later, he delivers Mocha as a demo. "Good work, Boogaloo. Ship it." "But sir, it's only a demo. We still need to ship it." Now you've seen this movie. You know how it ends. It's the most classic move in all of programming. Ship it. Mocha was supposed to be for amateurs and designers anyway. So who cares if it's buggy or half-baked? The real professionals are going to be using Java. And it was supposed to be, Java was supposed to be the language of the web. But we know how that played out. Run, write once, fail everywhere. And, so that's the classic blunder of programming, is that you never know when something you're going to write is going to turn up to be the most important thing on the internet. And that's what Mocha did. Mocha was written in 10 days, and then later renamed to LiveScript, and then later renamed to JavaScript to kind of tie in with Java, because Netscape and Sun were kind of in this thing together. The interesting thing is that in '96, Microsoft, took notice, and they created JScript. They reverse engineered the JavaScript that was in Netscape and created their own, version of it. They couldn't call it JavaScript at the time because it was trademarked by Sun, and so they called it JScript. The interesting thing is they did such a great job of reverse engineering that they included every quirk, every bug. I mean, it did exactly what the version of JavaScript that ran in Netscape would do with any of the code that it was given. Now, Netscape had seen Microsoft at work before, and they were fully aware of Microsoft's pattern of, embrace, extend, extinguish type of attitude. And so in an offensive move, they decided to standardize the JavaScript language, and they talked to the obvious candidate, the W3C. And the W3C responded basically with, no thanks, we have more important things to focus on, like Marquee and Blink. So they shopped around and they found a standards organization called ECMA in Stockholm, Sweden. And ECMA said, sure, we ain't got nothing better to do. TC39 was formed to be the committee, and in '97, they published the ECMA 262, which is the standards document for the language spec for the JavaScript language. They couldn't call it JavaScript either because JavaScript was trademarked by Sun. So that's where we get ECMAScript. The ECMA International Standards Committee, they called it ECMAScript. Now, JavaScript, as it's found in the browsers, is just one of several implementations of that standard. And then '98, we got ES2, which was mostly just a ISO certification update. ES3 had better regex and try-catch, better string handling. And then ES5, we had strict but wait a minute, 10 years between ES3 and ES5? What the crap? So Microsoft had won the first browser wars and basically sat back to watch the world burn. IE6 was what we were stuck with. And now the TC39, they continued to move forward, and there was a lot of debate and a lot of things going on with the next version of ECMAScript. But ES4, by 2008, it was so big and so complex. There was so much technical and political issues, especially between Microsoft and Yahoo and Adobe, that they made a decision to abandon it and move on, and basically adopted an early version of like ES 3.1 to just get something out the door and move forward with ES5. ES5 became known as the Harmony Edition because it was trying to bring harmony back to the JavaScript community. Interesting side note. Anybody remember this? Yeah. Macromedia Flash. Do you know, how did you program Macromedia Flash? ActionScript, which is just another implementation of the ECMAScript language standard. Flash and Macromedia, then Adobe, they started taking advantage of the ES4 spec early on, and they started implementing things. By 2006, ActionScript 3 had classes, interfaces, types, enums, default function parameters, modules. They had a package system. They had, Flash developers, if you were hardcore Flash doing ActionScript back in the day, you could argue that what you had 13 years ago is still better than what is in the JavaScript language today. Pretty cool. But it's, it's the beta, max, VHS, standard kind of stuff that happens. So let's go back to the TC39. The 10 years between ES3 to ES5 and another 6 years it took them to go from ES5 to ES6, they needed to fix their crap. They needed to fix their process. But adding features to JavaScript is no trivial task. The first rule of the TC39 Fight Club is you don't break the internet. Oh. Backwards compatibility has always been the highest priority for changes to the JavaScript language. That's why some of those quirks still continue to exist in the language today. They're codified in the spec to be there, because if those bad behaviors, those quirky things weren't there, and the internet would collapse and the world would explode as we know it. We can't fix it because most of the internet still depends on the crappy JavaScript behavior that exists. I submit my hypothesis that the Death Star superweapon was actually a very powerful JavaScript emitter. So the TC39 is made up of developers and implementers and authors, and it's the current ECMA 262 document. It's a living, evolving document. It's now over 1,200 pages, and they meet every 2 months for about 3 days at a time, and all their discussions are time-boxed. And JavaScript, to make a new improvement to the JavaScript language, it goes through a series of stages. Stage 0 is the straw man. It's zero index as God intended it. This is the idea stage. Lots of things get pushed to stage 1 or stage 0. Stage 1 is a formal proposal. There's a first draft created, and someone on the committee is selected to be a champion for that particular thing. They take ownership of it. Stage 2, there's a formal spec. The details are worked out. The syntax, semantics, all that's kind of, backwards compatibility is addressed. Stage 3 is a release candidate, and this is where some of the browsers and other things will start to implement this new idea. It's to get the feedback from actual usage and from the community. And they'll add new things to Chrome. There'll be like feature flags that you can compile Chrome with to be able to take advantage of those things. Or if you're using something like Node, you can use feature flags at the command line to enable certain new features. You can start trying them out and testing them. But there's still no guarantee that once it gets to this stage that it's going to be part of the new language. There's lots and lots of new features that have reached stage 3 that have been there for a long time and just continue to be, not make it across that final hurdle. So stage 4 is when things are ready to go. There's acceptance tests written. There's PR created for the 262 document. And the cadence that the TC39 committee has been on for the last several years is they make these selections somewhere around January, and then the final spec is published in, I think, June or July. This entire process is open. If you're curious, you can follow any of the, all their meetings are pretty well documented and noted. All the discussions for features and stuff are on their GitHub repo. All this stuff is open source. And yeah, it's pretty interesting to be able to follow it. And because they're on this yearly cadence now, that's why they switched from ES5, ES6, now it's ES 2015, 2016, 2017, 2018, 2019. So that's the signal that JavaScript will continue to move forward on, a yearly basis unless, I guess they run out of ideas. So despite the weirdness and the warts of JavaScript, there are still some amazing things that can be done with the language. Atwood's Law, you may have heard. And this is no more true than when you look at things like emulators that have been written entirely in JavaScript, such as the 82 Sinclair, the Commodore 64, an entire DOS implementation in JavaScript, an entire Linux operating system written in JavaScript. And God help us, someone has created an Electron application where you can run Windows 95 and do what you used to do with Windows 95, which is play solitaire. But you can do all kinds of things like IoT with Johnny 5. There's Node-RED. Like a guy that I used to work with, he created a remote garage opener where you could see, when his garage was open and be able to open and close it whenever he wanted to. Raspberry Pi, all kinds of cool stuff. This is a guy that has a live video production workflow, screen transitions, lower thirds, switching camera angles. He can do it all, and it's all written in JavaScript. There's this guy in the U.S., you may have heard of him, called Ken Wheeler. He's like the most American guy ever. And he's created this thing called the Crossbow, where he can operate a crossbow remotely using JavaScript. America. He shoots beer cans and stuff with it. This same guy, there's a high correlation between programmers and music, and so there's lots and lots of examples of using JavaScript with music, and apparently you can be dope if you try this thing. The drum machine. There's a web audio API that you can use that supports rhythms and instruments and complex time signatures and all kinds of cool stuff. This guy wrote a node-based web scraper that would call and text the minute a Miley Cyrus LP came back in stock, because I guess he really, really likes Miley Cyrus. And I created this thing called Charter, which allows me to create chord and number charts based on Chord Pro documents. It's pretty cool. There's games like, who wouldn't want to play this game? And then there's desktop. As you may have heard, things like Visual Studio Code is an Electron application, which is Node and Chrome and JavaScript and HTML. It's all, it's pretty cool. The GitHub client is Electron. The Slack client, destroys your RAM on your computer. It's fantastic. Mobile apps, there's just tons, and is just scratching the surface what you can do with JavaScript. So, to put some closure on this talk, here are some of my thoughts on the future of JavaScript. So in the life of JavaScript so far, we've seen lots of languages and ideas that have come in from all different areas that have kind of influenced the JavaScript language into what it is today. The TypeScript community, and I really appreciate Mike's presentation. Man, my mind was completely blown. TypeScript, they would have you believe it solves every problem in JavaScript, it seems like, when you read it. But TypeScript is certainly becoming a standard for the type system for JavaScript. Eric Elliott, a well-known author and speaker and open source developer in the JavaScript community, he recently wrote a scathing article on the cost-benefit analysis of TypeScript that a lot of people disagreed with. I don't really know. I'm not a TypeScript developer, so I can't really say one way or another. But he goes on to say that, contrary to a lot of the hype, that his experience has been that it causes a lot of more friction, a lot more time onboarding, and that the types of errors that it helps you to solve or prevent is just a small fraction of the real errors. Well, duh, you can make a lot of mistakes no matter what you do, whether it's JavaScript or TypeScript, you can still screw up an application pretty good. So TypeScript isn't going to save you from making, some of the, some types of mistakes. But I've had lots and lots of conversations from people who have been using TypeScript and just absolutely love it and have had all kinds of great success with it. And so your mileage may vary. And there's lots of benefits. I find it interesting that there are several people on the TC39 who are vocal about being TypeScript users. And my prediction is that we may one day start to see some of those most valuable ideas from TypeScript start to make its way into the ECMAScript specification. And if that happens, if we start getting a real type system in JavaScript, maybe there won't be a strong case for TypeScript, in the future. Kind of like we don't really do CoffeeScript anymore. Anyway, regardless, I believe there's a strong case for continuing to invest in JavaScript. It's not going to go anywhere. It's going to be, whether we like it or not, the universal, ubiquitous language. It continues to be. Can't stop it, won't stop, right? So, last but not least, I believe that all of us in technology have an incredible opportunity to make a positive impact on the world with the skills. Our skills in programming and the things that we do, they're, for 99% of the world, what we do is magic. And we can do some amazing things. We can change, our workplaces, our communities, and the entire world. So I challenge you to take the things that you're learning and you get out there and you be awesome. Thanks.